Please you start reading about the regression.
Okay, sir. Today we'll study regression analysis. Regression analysis is a statistical technique used to understand the relationship between variables. It is a powerful tool in data analysis that helps researchers and analysts make predictions, identify patterns, and draw meaningful insights from data. At its core, regression analysis examines the relationship between a dependent variable and one or more independent variables. The goal is to find the best fit line or curve that minimizes the difference between the observed values and the values predicted by the model. This line serves as a mathematical representation of the relationship between the variables, allowing for predictions and analysis of their interdependence. One of the key concepts in regression analysis is the distinction between simple linear regression and multiple linear regression. Simple linear regression involves one independent variable, while multiple linear regression deals with two or more independent variables. By using regression analysis, researchers can quantify the impact of each independent variable on the dependent variable, helping them understand the underlying patterns in the data. Regression analysis finds applications in various fields, including economics, finance, biology, and social sciences. For instance, in economics, it can be used to predict consumer spending behavior, sorry, spending based on income levels. In finance, regression analysis helps investors assess the relationship between different assets and make informed investment decisions. In biology, it aids researchers in understanding the impact of various factors on biological processes. Moreover, regression analysis provides valuable insight into causality and correlation. While correlation indicates a relationship between variables, regression analysis delves deeper by identifying the strength and nature of this relationship. It helps researchers determine whether changes in one variable directly cause changes in another, providing a basis for informed decision making. In addition to its predictive value, regression analysis also offers tools for assessing the accuracy and reliability of the model. Measures like R squared and p values enable researchers to evaluate the goodness of fit of the regression model, ensuring that the, the conclusions drawn are statistically significant and reliable. In conclusion, regression analysis is a fundamental tool in the realm of statistics and data analysis. Its ability to uncover patterns, make predictions, and quantify relationships between variables makes it indispensable in various fields. By understanding the basics of regression analysis and its applications, researchers and analysts can harness its power to gain meaningful insights from data, driving informed decisions and advancing knowledge in their respective domains.
Okay, stop. So what we have understood, who can summarize? What is regression analysis? And what is the difference between regression and the correlation?
So,
Yes.
so correlation just develops or helps us to understand that there is relationship between two variables or not. But regression analysis helps us to find the strength of that relationship also.
No, correlation coefficient indicates strength of relationship. That is okay. And regression is important for prediction. Okay. Regression is used for prediction purpose. For example, I am getting that your intelligence level is 140. So I can predict that your academic achievement will be very high. Okay, on which basis? Because I have noted that the correlation between academic achievement and intelligence is 0.85. Okay, so therefore, based upon the correlation coefficient, I can think that, okay, that means if your IQ is high, it is expected that your academic achievement will be high. And for that reason, we have to do the regression analysis. If we find that is the regression coefficient is very high, that means we can predict. Okay, so correlation is the base. If there is no correlation, we cannot think about the regression. And this correlation is the linear correlation. Okay. This is clear? Any question? Okay, no question. Now, Shima, you start assumption.
Good evening, sir.
Good evening, Shima.
Now we are going to read the assumption of regression analysis. The first assumption is linearity. There is a linear relationship between the independent and dependent variables. Independence. The observations are independent of each other. One data point's outcome should not influence another. Homozygosity. The variance of the residual, the difference between observed and predicted value, should be constant across all levels of the independent variables. Normality. The residuals should be normally distributed. This assumption is important for hypothesis testing in confidence interval. No perfect multicollinearity. The independent variables should not be perfectly correlated with each other. High correlation can cause problem in estimating individual regression coefficients. Additivity. The effect of the change in an independent variable on the dependent variable is consistent regardless of the value of other variables. Checking these assumptions is crucial to ensure that the results and interpretations of the regression analysis are valid and meaningful. Various diagnostic tools and statistical tests are employed to assess these assumptions.
Correct. Okay, thank you. So stop it now. So what we have understood, the first one is the linearity. Okay, so both independent and dependent variable, both will be linear in nature. For example, academic achievement, that is linear, and IQ, that is also linear, or intelligence score, that is also linear. Okay, and the second part is the independence. Here it is written, the observations are independent of each other. So that means when we are collecting the data, we are collecting independently both academic achievement test as well as the intelligence test. One data point outcome should not influence another. Homozygosity, the variance of the residuals. Residuals means the differences between observed and predicted values. Okay. So that is called the residual. Residual basically error. That should be constant across all levels of the independent variables. Normality. The residual should be normally distributed because you are collecting the data following the normality assumption. And no perfect multicollinearity. Perfect multicollinearity means two variables are there, the correlation is more than 0.99 or 0.96, like that. So if the two variables, they are highly correlated with each other, so there is a high chance for the multicollinearity. If multicollinearity is there, that means you are measuring the same variable in different names. Okay. So this is called the redundancy error. So to solve the multicollinearity, we are using the factor analysis or principal component analysis. Next one is the additivity, the effect of a change in an independent variable on the dependent variable is consistent regardless of the values of other variables. Okay, now the interpretation. Who will teach? Okay.
Hello.
Shoko. Yes, Shima.
Sir, I have one query. Sir, what is observed and predicted values in correlation? Observed means the response which we are getting from our subject.
Yeah. So that is the observed value. And the predicted value means there will be a regression line. So the regression, the values which are very close to the regression line, that means they are best fit. This observation is best fit. And if the observed value is far away from the regression line, that means there is a differences. Okay.
Okay,
There
sir.
is a
Thank you,
difference
sir.
between. Now, Kavita, please you start interpretation.
Okay, sir. Interpretation. Regression analysis is a statistical method used to examine the relationship between two or more variables. It's commonly employed to predict the value of one variable based on the values of others. Here's a basic interpretation. Variables relationship. Regression analysis shows how the value of the dependent variable, the one being predicted, changes when any one of the independent variable, the predictors, is varied while keeping other predictors constant. Regression equation. The analysis produces a regression equation which represents the best fitting line through the data points.
One second. Yes, Kavita, now you continue.
Yes, sir. The regression equation mathematically expresses the relationship between the variables. Now, so just a second. Coefficients. In the equation, each independent variable has a coefficient which signifies the change in the dependent variable or a unit change in the independent variable, assuming other variables remain constant. R squared. This value ranges from 0 to 1 and represents the proportion of the variance in the dependent variable that is predictable from the independent variables. A higher R square indicates a better fit of the model to the data. P-values. These indicate the significance of the coefficients. The low p-value typically less than or equals to 0.05, suggests that the variable is statistically significant in predicting the dependent variable. Residuals. Residuals are the differences between the observed and the predicted values. By analyzing the pattern of residuals, you can check if the model is a good fit for the data. Assumptions. Regression analysis assumes linearity, a linear relationship between variables, independence of residuals. Each data point's residual is independent of all others. Homoscedasticity, constant variance of variable residuals, and normality of residuals. Understanding these aspects helps in drawing conclusions about how changes in the predictors are associated with changes in the dependent variable, and whether the model is a good representation of the real world relationship between the variables. Thank you, sir.
Thank you. So now we will examine the regression analysis of one data. So please you follow me. What happened? This is visible?
Yes, sir, it's visible.
Okay. So there are 9 variables. Okay, 9 items are there. So 9 variables are there. Then here we can find out analyze. In the analyze, I am getting regression. Regression. Next is the linear. Okay. So my dependent variable is total score. Okay. And my independent variables are these. This is clear. Now it is statistics. Estimates is there. And if you are interested, you can take the confidence interval. That is not required now here. You can check the plots. Continue. Plots is there. So this is not required now. Options 0.05 level. That is okay. Okay, so I am clicking OK. So here I find that is the dependent variable is single, and that is the metric data. And this is the independent variable. They are also the metric data. Then OK. I am sharing you the output data now. This is the output data. So this is the R square very high. All requested variables are entered, R square very high. Okay. And so we can think about very high R square. Therefore, it is better to do regression, linear, method is enter. Instead of enter, I am writing stepwise. That is better. And here it is written statistics, that is R square change. Okay. Then continue. After that, okay. Let's see. Model summary. Okay. So the first model is the new solution. Okay. That is 46% variance accounted. And when it is added the new solution and the feedback both, then it becomes 67. And when it is new solution, feedback, and good job, then it becomes 88%. This is visible to all of you?
Yes, sir.
Okay. And so in this manner, you will find the predictors. Okay. And when I find that is the 8, that is H, it is written H. H means first a new solution, then feedback, then good job, try again, new strategy, career impact, better feeling, drive. So all of them included, that is the 99%. And here you can find, 98%. 98% is the R square. That means these items are highly correlated with the total score. And here you can find out R² change. Okay, so initially it is 4.465 because R² is 0.465 and it is 0.671. 0.671 minus 0.465. Okay, that will be the 0.207. So that is the R² change. How much change? Now you can find out that next variable is the C. Okay, this C means new solution, feedback, and good job. That is the this. So gradually you will find that is the R² is changing. Okay. And whether this is significant? Yeah. So this change is also significant. And this is the DF value. And this is the significant of change. So what I have done the stepwise multiple regression. Okay. I am using the stepwise multiple regression. 1, 2, 3, 4, 5, 6, 7, 8, 9. So all the 9 variables, they are accounted. So what does it mean? That means the linear combination of these 9 variables could predict 98% of the variance of the dependent variable. So this dependent variable is the total score. So it can predict 98%. This is clear to all of you?
Sir, I have one doubt.
Yes, please.
Sir, what is the use of R² change?
Acha. R², that indicates the prediction. R, capital R indicates the multiple correlation. And R² indicates the prediction.
So why we calculate the R² change?
R² change means if we account the first variable, so we will get only the 46%. Okay, change we can expect by using the new solution. And when you add it, that is feedback and the new solution, both, then it becomes 67%. So how much change is there? That change you can get this R² change or delta R². And this delta R² also significant. So when we find that is all the variables, okay, in together, they could predict the total score 98% of the total variance. That means we can tell that is for achievement motivation, the linear combination of those variables are very much important. And this is the stepwise multiple regression. Because when all the variables are correlated, it becomes 1. That is theoretically okay. And for that reason, we can do the dimension reduction, that is the factor analysis. Then we can do this thing. And there is a rotation. You can click the Varimax rotation. Continue. There is extraction. Here it is written script plot. You can click it. Continue. There is a option. Option, it is sorted by size. So you can consider. Continue. After that, okay. Is it visible now?
Yes, sir.
So this is the factor analysis I have done. And this is the communalities. This is script plot. Okay, so
So what does this show?
that means we can consider only these two factors. And here we can find out that is the first factor includes new strategy, new solution. Next is career impact, good job. Better feeling. And drive also. And the second factor includes listing goal, try again, and feedback. Okay, because all the variables, they are highly correlated with each other. If they are highly correlated with each other, what does it mean? There is a chance for the multicollinearity. Okay, therefore, we have to remove the multicollinearity. For that reason, we are doing the factor analysis. And by using the factor analysis, multicollinearity issue has been controlled. So we find these 5 variables. They are very important for the first factor, and the second factor that includes this variable. Last 3, listing goal,
How
try
do you
again.
differentiate between the two?
No, sorry. Listing goal and this one, feedback. Try again also, correct. Because it is the 0.019 for first factor. Okay. And this is for second factor 0.813. and try again 0.155, and here it is 0.557. Here it is feedback 0.390, but it is 0.599. That means these three, they are accounting maximum variances of second factor, and other 6 variables, they are accounting maximum variances of the first factor. Okay. So if we get the factor score of these 6, for example, okay, Shima, are you here? Shima?
Yes, sir.
So please you write down new strategy, new solution, career impact, good job, and better feeling. Oh, next is the drive.
Good job.
Have you written?
Sir, better feeling
Next is the drive.
and drive.
Okay. And the second factor that includes listing goal, try again, and feedback.
Yes, sir.
Okay, so the assumption is that first 6 factors, 6 variables, they are internally consistent with the first factor. And last 3 variables, they are internally consistent with the second factor. For internally consistent, we can do this analysis. We can go to the scale, and scale is the reliability analysis. Now you tell me what about the things I have told. New strategies. Is it visible to you?
Yes, sir.
New strategies. Next one.
New solution. New solution.
New solution.
Career
Next
impact. Career impact.
Career impact.
Good job.
Good job.
Better feeling
Better feeling.
and drive.
And drive. Okay. Okay.
Yes,
So
sir.
now here the model is alpha. That is the Cronbach's alpha. I am clicking OK. So I find the Cronbach's alpha is 0.735. Okay. This is clear?
Why we choose alpha?
Yeah, this is the reliability statistics and Cronbach's alpha. 0.73.
So could you please explain why we chose the model?
Yeah,
How
because
we select the model?
correct. Because I find that these variables, they are internally consistent, okay, with the first factor. Therefore, I have selected only these 6 variables separately, and then I am checking, that is whether they are internally consistent or not. Therefore, I am doing this alpha. So if I do the Cronbach's alpha, then I can get, that is, yes, they are internally consistent, and their internal consistency is 0.73. Now there is another factor, factor 2. So again, I am doing the same thing for the scale reliability analysis, and that will be try again feedback listing goal. So I am clicking this, it is set. Now I click the Try again. Feedback. And listing goals.
So could you please show us the models also, the other ones?
Yeah, other one already I have given, na, 0.73.
No, sir. The option here, the model that is alpha, there's the drop down box.
Rather than alpha.
What are the other models available, and when we will
other than achha. That is split up, Gutman, parallel, strict parallel. So there are different models are there.
So basically these are the statistical technique from which we get the reliability coefficient.
Yeah, reliability coefficient. And for that reason,
yes, sir.
The data collection procedure and the questionnaire arrangement will be different.
Like alpha denotes the Cronbach alpha split half, means we are dividing the test into similar halves, two groups. So that's why, because I think he who is asking this question is not very clear about the reliability coefficient and methods.
So I am clicking this. Okay, now the second factor is not very strong. It is 0.56. Okay, but the first factor is very strong because it is 0.73. So for the analysis purpose or for the intervention purpose, we can use the first factor because the first factor that is 0.73. Okay, so out of these 9 variables, we can consider the first factor. For our analysis. Okay, so this is all about the regression, correlation, regression, and also I have shown the factor analysis. I have shown you, and also the convex alpha. So you have learned many things in one class. Now, do you have any question?
Yes, sir.
Yes, which question? Now tell me.
Sir, can we learn factor analysis in a separate class? Sir, there is nothing to gain in one class about factor analysis at SPSS. Because for item analysis,
it is not in your syllabus, but still I am getting the data is moving in the same manner. So I am showing
yes.
it. It is not in your syllabus.
Yes,
because that is
that's
very
why I am
advanced
asking.
stage. Yeah, that is very advanced stage. Because finally,
it is.
Yeah, many things are there for factor analysis.
Yes, sir.
I am getting chance because the data is like that. So I am showing you.
Okay, sir.
Sir, I have one request.
Yes.
Sir, could you please explain from the next class, could you please explain what are we doing and in which case we will follow the steps that we do in the SPSS?
Oh, that is been simple. Only thing, first you have to click the linear and then there is a regression. And when you click the regression, automatically you will get the dependent variable and the independent variable.
Yes, sir, that I got. Sir, I'm talking about factor analysis and the other steps that you follow.
No, factor analysis is not in your syllabus. Factor analysis is not in your syllabus. I am just finding out the variables are highly correlated with each other. Therefore, I am thinking possibly I can show the factor analysis. And after the factor analysis, I am showing the convex alpha also. So whether the factors are good or bad, that again, you will get that information. But it is not in your syllabus, so you don't worry.
Sir, but you follow some steps and we must know why we are following that.
Because if there is a multicollinearity, na? If the variables are highly correlated with each other, that means there is a chance for the multicollinearity. And you will find that these 9 variables, when they are correlated, it becomes 1.
Yes, sir.
So when it is 1, that means multicollinearity possibility is there. So we have to control the multicollinearity. That is in the regression analysis, I have already told you, that is the multicollinearity assumption.
Yes, sir.
That should not be there for regression analysis. Therefore, I am showing you. But that is not required for your case.
Yes, sir.
So it is always better to use your own data. If you have your own data, then you can do the analysis. And if you do not have the data, then we will provide the data. And when the data is there, that means the variable that you have to understand. So please, you enlist yourself to Twinkle so that Twinkle can give me, that is how many students are interested to get our data. Okay. Okay, thank you. So now I am closing.
Thank you, sir.
Thank you, sir.
Thank you,
Thank
everybody.
you, sir. Good night.
Good night, sir.
Good night.